Welcome to the microscopic battleground. We're exploring how drugs successfully break into your cells, a crucial process called drug absorption. Think of your cells not as soft targets, but as heavily guarded high-tech fortresses. Your cells are surrounded by a semi-permeable plasma membrane, a sophisticated wall that controls what enters and exits. Embedded in this wall are membrane proteins. They act as structural supports, enzymes, and most importantly, locked gates or receptors. For a drug to actually heal you, it has to breach this wall, a process called absorption, where the drug enters your systemic circulation. But how does a medicine actually break in? Some drugs take the easy way out using passive transfer, methods that require no energy from the cell. Highly lipid-soluble drugs use simple diffusion, moving like ghosts right through the biological barrier from an area of higher concentration to lower concentration, requiring zero energy. Meanwhile, water-soluble drugs of low molecular weight use, quote, filtration, squeezing through tiny membrane pores driven by hydrodynamic pressure. But what if the drug is too big to sneak past? It needs a VIP pass for specialized transport. In, quote, facilitated diffusion, a drug crosses the membrane using a dedicated protein carrier system. This method is quick, but it still doesn't require cellular energy. However, if a drug needs to travel against its concentration gradient, it uses, quote, active transport, which requires both a carrier and a massive expenditure of cellular energy. And for the largest molecules, too big for any gate, the cell membrane literally swallows them whole in a process called endocytosis. How you take a drug completely changes its invasion strategy. Let's look at oral administration. Taking a pill orally through the alimentary tract, like your stomach or intestines, is generally safe, convenient, and economical. But this is the scenic route. The onset of action is incredibly slow compared to other methods. Before absorption, the drug must survive the treacherous, highly acidic pits of your stomach, where digestive enzymes might destroy it completely before it even works.